Yeah, so I'm the Dr. Minkwan Kim at the University of Southampton. So today I'm going to give you a brief talk about our plasma propulsion technologies developed through the support of the SPRINT program and the European Space Agency funding, and a little bit some of the multidisciplinary applications, how the plasma propulsion technologies actually help to the responding the current global coronavirus pandemic. So initially, from the European Space Agency funding, we have developed the concept of the all-printed propulsion system, which is called the ALPS. So ALPS is using the conventional plasma propulsion system with the printed electronics to make the entire the propulsion system can be printed in the thin substrate. So recently, we have through the SPRINT program. So we extended this concept. Basically, through the SPRINT program, we developed the high power pulsed plasma system, which is called the MEC drive. So the picture in here is the picture of our cathode arc thruster, which is the core of the ALPS. So we merge this one for the high voltage, the pulsed system of the MEC drive. And we call that is the pulsed power, the cathode arc thruster, which is called the PPCAT. So recently we successfully operated this one in our test chamber. So now we have some on-orbit demonstrations, which is the plan to launch in the summer 2022. So we have further developed this concept for generating the automated deorbiting block. So this concept of the automating deorbiting block is to consist with the PPCAT and some of the control and the command module. Thus, it has the scalable the deorbiting system for various the WDs. So this is some of the operational concept of the current system. So currently, there are some of the various active W removal technologies proposed. So one of the key challenges of the active W removal technology is how the satellite is attached to the target satellite. So we approach the technical challenges a little bit different ways. So we have the big mothership, and the motherships contain several deorbiting block. And actually, once the mothership is close to the target WDs, the mothership can release several deorbiting block. So some of them might successfully reach to the target, and some of them might be not. If the deorbiting block is not successfully attached to the target, so we have some pre-programmed the signal, it automatically ignites its propulsion system, and the deorbiting block itself is deorbit by themselves. So it does not remain in the orbit for the long time. So case is if the deorbiting block is successfully attached to the target. So the block will send a signal to the mothership, and the mothership send another signal to command it, okay, it is time to ignite the system. So once it ignites the propulsion system, it decreases the velocity of the target WD and successfully remove from the orbit. So currently we are prototyping some of the system. So we're testing the propulsion module already, and now we are testing a communication and the command module to ensure it can be operated sustainably. So during the kind of the project, so this kind of the testing required to operate in the vacuum. So it's quite challenging to us to every time we removing the air and waiting a couple hours, repressurizing it, diagnosing again. So to reduce those challenges, we developed the plasma technique, which is able to generate in the air. So that helped us to develop testing the system and developing the new diagnostic techniques. At the same time, we recognize that this kind of the low temperature plasma is some potential. So it has the unique capability for bactericidal and the virucidal. So then we have funded from the UKRI and the EPSIC. Actually, we look at this one is to decontaminating PPEs in the UK. So in the initial stage of the pandemic, so in the globally, we have suffered like the PPE shortages, and now those PPEs, the damaging our environment. So most of them is made by the plastic, and some of them might be recycled. So we think using our plasma technology from the space might be we can just help to recycle the PPE. So we have to test this one against the actual coronavirus. We're using the alpha variant from support from the DSTL. So basically, there's the baseline. One is the negative, means there's no virus in there. So positive is purely the coronavirus in there. So we expose to the sample the face mask with the plasma up to 5 minutes. You can see pretty much like we confident is like 99.99% of the virus was completely removed by the plasma technologies. So this is, I think, one of the good example how the space-oriented plasma technology can be translated into the biomedical areas. Okay, so thank you.